Alright, physics. Again, we're back. I'm taking a look at the bulletin board for you. It's a little out of order here because I finally figured out what my problem was, so everything uploaded simultaneously. The reference table is here, and replacing your supply list is now this weird thing called LoggerPro download codes. Again, Windows 10, Mac OS 13, 14, 15, older computers, oh, it does go back to XP and Vista. Imagine that. And it goes all the way back to 10.7, which is, all right, that's very old. I imagine that for many of you, you will simply either choose this one for Windows and this one for Mac. If you click on those links, it will give you a .exe file. You'll do that, do the installer, and once you've gone through those, you should install a program, and the program should look like this. Now, this is a lovely graph, but right now it doesn't tell me anything, right? I can type in numbers and it will do things for me, and that's very nice. And look, it plots them, and if I go too far out of bounds, then it just changes, it automatically updates things for me. Right now you can't see it, but there is a point way, it's hidden by me. I'm going to do my best to get rid of that, but let's just clear out all of this. We don't need any of those. Oh, shush. Okay, cool. Sorry, it's my computer's yelling at me. So what I'm going to do is I'm actually going to use our data, that grass data, right? So the first point was 0, 0. The next point in our data, which I have pulled up, is x-axis is time, y-axis is distance. I'll show you how to label that shortly too. So 0.3 seconds for 3 meters, 0.97 seconds for 6 meters, 1.26 seconds for 9 meters, 2.6 seconds for 12 meters. Okay. So, looking at our graph now, it's very clear that we need to scale this a little more appropriately. Auto scale is an option. And what it just did, it did kind of move. I'm going to disappear my face for a second here. And if you look, there's now a point way up here. This is at 2.6, 12, right? Now, I don't like that being right on the edge of the graph, so I can manually adjust the scale of the x-axis and the y-axis. In order to do that, all I would do is right-click on the graph and look at the graph options, because I'm interested in changing information about the graph. The first thing that I'll do before I even look at the axis, probably title the graph. So this is distance versus time on grass. And I'm looking for the axes options. I'm not going to do anything with these labels here. There's an easier way to label what's on this axis and what's on this axis. But I would like the scaling, and it said auto scale. I'd like the top to be 15. And I'd like the rightmost point on the x-axis, again, x-axis, scaling, I'll go from 0 to 3. And I'll hit done. And what will happen is, here's my title, here are my points, right? And there, we've gone all the way up to 15, so now this is right on the graph, and this uses plenty of the graph. This feels like an appropriately scaled graph. Now I would like a way to say that this is time measured in seconds, and like a way to measure that this is distance measured in meters. In order to do that, all I would need to do is double click on this, and if I do that, this is the x-axis. I would like to name this distance. I would like the units to be meters, and if I do that, I hit done, boom, look, it did it for me. Now it measures distance in meters, 1, 2, or oh, that's wrong. That's not correct. I was wrong, kids. That should have been time in seconds. Now it's right. 1 second, 2 seconds. It didn't quite take 3 seconds to get all the way out there. I'm going to do the same thing for the y information. This one actually is distance in meters. So I have my distance versus time graph. Distance on the y-axis, time on the x-axis. Look at that. Everything's great. Now when it comes to making like the shape of the graph, interestingly, this first section actually seems to be a fairly straight line. I know there's a little bit of a dip here, but this first section looks to be a straight line, and then it maybe curves off. Maybe the whole thing is a curve. I think that if we somehow manage to exclude this point, we can make a decent curve here. Now I don't know that we can. There's not a good way to do it. But what I can do is I can analyze this. And if you remember, a few times last year, Miss Summers and I asked you to do a best fit line, or maybe a best fit curve, depending on what graph we were making. You can do the same thing right here. If you analyze it and you ask it to make what we call a linear fit, then what it will do is literally try to make a single line of best fit. Now I would be curious to see. I want you to notice that it brackets off. It's including this point here, and it's including this point here. If I move my mouse cursor over this bracket, it changes what it looks like, and it says click and drag to reset the range for the linear fit. So let's say I wanted to not include that point. I totally could. And that actually looks like a pretty good linear line. I want you to notice something else down there. There's this box of information here. If you look at the slope of this graph, this is a distance versus time graph, you should know something about the slope. The slope should tell you the average velocity for that section. And if you look here, it totally does. Not only does it tell you the average velocity, it even has units. It tells you that the average velocity for these 4 points for the traveling of over these 4 spots was 6.555 meters per second. Right. I could actually check myself. What was the speed for the first 2? It was 10 meters per second. That's what I would have calculated. I could check what was the speed here. 4.5 meters per second. That was what we calculated during class. I could check what was the speed here. 10.34. Again, what we calculated during class. 10.3. And then finally, for the last section, it was 2.2. So it slowed way down. I would be inclined to say that this data point is something of an outlier. Because this is a really pretty good linear fit. Which is interesting. Something else to talk about, right? As far as the analysis of your data. Now, perhaps a straight line is not the best way to analyze this. Perhaps I should have done some kind of curve. A new little window pops up. And you could do a linear fit and try it, and it would show exactly the same thing. But if you tried a quadratic, just tried it, I want you to look at the shape of the graph. Ignore the numbers here. These numbers don't mean anything to you right now. But look at the shape. It curves upwards and it tapers off like this. Think about how that corresponds to what we saw here. It looks just a bit like this. It's moving forwards because it's going low to high, and it's slowing down. Is that what you would observe if you kicked a ball in the grass? Would you observe that it would move forward and slow down? And it's all connected, all right? The graph, the math, and what you see all connects, and it eventually it'll make more sense. Right now I know that it might not make a lot of sense, but it'll eventually all make sense. Why is this? Okay. That's interesting. I don't know why this didn't change. That's fine. It's not a big deal. Now, what I'd like you all to try is to create graphs of distance versus time for your three different things. Now your graph will look like this. And I'd like you to try to do that curved fit for each one. Actually, I'll let you use your judgment. For this one, I believe that the curved fit is the best fit. That may not be the case for the dirt. That may not be the case for the turf in the batting cage. So I will allow you to use your judgment. When you analyze it, should you analyze it as a linear fit, or should you analyze it as a curved fit? I'll let you decide. Okay? Now, it's possible for you to print this graph. And when you do, what I would recommend is that you print it with a footer. Just say put your last name on it. Right? And then you would hit OK, and the next print thing would come up. When you do this, before you print to wherever you print, now I don't have a printer installed on my computer right now, but when you print this, go to Properties and just, oh, it didn't do it. Some places you can just make sure it goes landscape. Make the layout landscape so it prints out this way instead of this way. It'll make your graph look better, trust me. Right. For this graph, you'll want to print everything. In the future, you might want to literally only print the graph. There is an option for that. You can literally just print the graph and it would do the same thing. It would ask you, make sure to change it to landscape. I wonder if I can make that a default. I cannot. Okay. In any case, right? This is a program. This is a way to look at data. Specifically, a way to look at data that you've collected, whether you do it by hand or digitally, which is another lesson for the future. But we can make these best fit lines, and we can actually make sense of what these numbers are. Can't do it yet, but soon, right? Soon is going to be another one of my mantras. I will answer your question soon. No matter the case, hopefully you are able to calculate your velocities, calculate your accelerations, calculate an average acceleration, and then you are able to create some graphs. You do not need to bring the graphs in, but know that we will talk about the graphs the next time I see you. We'll talk about these graphs and the graphs from the assignment that I didn't go over today during class. Now, your calculations will functionally be a quiz grade. Right? It will, so show your work, and guys, this is a way to check. You can check your math, but show your work, show your process, make sure that you're able to walk your way through it. All right? This graph, and my goodness, so many windows open. The graph that goes with this assignment, and the graph that goes with, or the information that goes with this assignment. So these questions, I will go over and we will look at all of that as examples, as things to work through on your next A-Day. All right. This video is long enough. If you still have questions, if I have not been clear, let me know. All right. I think I've been clear. Velocity, acceleration, average acceleration, uploaded online. Graphs for you. These graphs, or these questions, and the graph from before, bring to class. Do upload it. Do upload how you did here, or bring them to class. I'm not grading you on accuracy here. I'm grading you on please do it, so that I know that you're doing it. But I'm more worried about discussing and seeing how you're doing. All right? Okay. All that being said, I will see you all soon. And make sure that you're staying sane, but also safe. Take care, kids.